How many concurrent requests does a single Flask process receive? I'm building an app with Flask, but I don't know much about wsgi and its HTTP base, work suck. When I start serving a Flask application with Gunicorn and 4 worker processes, does this mean that I can handle 4 concurrent requests? I do mean concurrent requests, and not requests per second or anything else.
No, you can definitely handle more than that. It's important to remember that deep down, assuming you are running a single core machine, the CPU really only runs one instruction asterisk at a time. Namely, the CPU can only execute a very limited set of instructions, and it can't execute more than one instruction per clock tick. Many instructions even take more than one tick. Therefore, most concurrency we talk about in computer science is software concurrency. In other words, there are layers of software implementation that abstract the bottom-level CPU from us and make us think we are running code concurrently. These things can be processes, which are units of code that get run concurrently in the sense that each process thinks it's running in its own world with its own, non-shared memory. Another example is threads, which are units of code inside processes that allow concurrency as well. The reason your 4 worker processes will be able to handle more than 4 requests is that they will fire off threads to handle more and more requests. The actual request limit depends on HTTP server chosen, I/O, OS, hardware, network connection, etc. Good luck. Asterisk instructions are the very basic commands the CPU can run. Examples: add 2 numbers, jump from one instruction to another.
Flask will process 1 request per thread at the same time. If you have 2 processes with 4 threads each, that's 8 concurrent requests. Flask doesn't spawn or manage threads or processes. That's the responsibility of the WS gateway, e.g. Gunicorn.
When running the development server, which is what you get by running app.run, you get a single synchronous process, which means at most 1 request is being processed at a time. By sticking Gunicorn in front of it in its default configuration and simply increasing the number of workers, what you get is essentially a number of processes, managed by Gunicorn, that each behave like the app.run development server. 4 workers equals 4 concurrent requests. This is because Gunicorn uses its included sync worker type by default. It is important to note that Gunicorn also includes asynchronous workers, namely eventlet and jevent, and also tornado, but that's best used with the tornado framework, it seems. By specifying one of these async workers with the worker class flag, what you get is Gunicorn managing a number of async processes, each of which managing its own concurrency. These processes don't use threads, but instead coroutines. Basically, within each process, still only one thing can be happening at a time, one thread, but objects can be paused when they are waiting on external processes to finish, think database queries, or waiting on network I/O. This means, if you're using one of Gunicorn's async workers, each worker can handle many more than a single request at a time. Just how many workers is best depends on the nature of your app, its environment, the hardware it runs on, etc. More details can be found on Gunicorn's design page and notes on how jevent works on its intro page.
Currently, there is a far simpler solution than the ones already provided. When running your application, you just have to pass along the threaded equals true parameter to the app.run call like. Another option, as per what we can see in the worksug docs, is to use the processes parameter, which receives a number is greater than 1 indicating the maximum number of concurrent processes to handle. Threaded. Should the process handle each request in a separate thread? Processes, if greater than 1, then handle each request in a new process up to this maximum number of concurrent processes. Something like. More info on the run method here, and the blog post that led me to find the solution and API references. Note, on the Flask docs on the run methods, it's indicated that using it in a production environment is discouraged because, quote, while lightweight and easy to use, Flask's built-in server is not suitable for production as it doesn't scale well. However, they do point to their deployment options page for the recommended ways to do this when going for production.
Flexible,